8.4 rational expression. So we're talking about rational expression. It's a quotient. Quotient means dividing of two polynomials. That's what we're talking about, dividing with letters, essentially. So when we're doing these problems, you have to state any restrictions, because when we have a quotient, that's dividing, and you cannot divide by 0. So when I'm doing this problem, the first thing I'm going to do for A is to factor. So I'm factoring, it's what two numbers multiply to get 10, add together to get 7. So that'd be plus 5 and plus 2. Multiply to get 10, add to get 7. Then multiply to get negative 10, add together to get negative 3 would be plus 2 minus 5. At this point, you always want to focus on the denominator. This cannot equal 0. So the bottom part cannot equal 0. We have x minus 5. We have x plus 2. So because of this, right here, we actually have two different numbers. So my restrictions will be both of these cannot equal 0. Because if one of them equals 0, 0 times anything will be 0. So my restriction would be x cannot equal, I would add the 5 here. Here I would subtract my 2. So that's my restriction. You should always find your restriction before you simplify. Because, I would subtract my 2. So that'd be negative. So when I'm looking at this equation, you can only simplify if there's multiplying in between two things. So since it's multiplying, since this whole thing is multiplied and this whole thing is multiplied, they're the exact same. Both of them are adding. These two can cancel each other out. So what I'm left with is x plus 5 over x minus 5. This right here is my final answer. So you need to have your restrictions and your simplified equation. So then look at B here. I don't have any factoring to do because it's all multiplying straight across. But I do have to state restrictions. Whenever you have a variable on the bottom of your fraction, like here, anything on the bottom of the fraction cannot equal 0. So my restriction, because we have x on the bottom, that cannot equal 0. We have y on the bottom, that cannot equal 0. Because if it did, it'd make the whole thing 0. So now I'm going to focus on my numbers. 24 divided by negative 6 will give me a negative 4. So 24 divided by negative 6. Now when I look at my x's right here, I have more x's on top, and I have to remember back to chapter 6. When I have division with exponents, I subtract them. So 3 take away 2 would give me 1. You don't need to write the 1 there, but you can. My y's, I have more y's on bottom. And again, I take the larger one then, minus the smaller, so 3 minus 2 would give me 1. If you didn't do it that way, you could also do 2, because it's on top. 2 take away 3, that would give you y to the negative 1, and because it's negative, you have to put it on bottom. So right there is my final answer. I'm going to pause the video. I want you to try to do C and D by yourself right now. So first thing I did is factor. So when I have factored, I have x plus 4, x minus 2. On bottom, x minus 3, x minus 2. Again, multiply to get this, add to get this. So undoing their foiling. The bottom is where we have the restriction. So this bottom part cannot equal 0. So if I said both of these cannot equal 0, I'd add the 3. So x can't equal 3. I would add the 2. X can't equal 2. Because it's multiplying here, these two cancel each other out, leaving with x plus 4, x minus 3. When you look at D, whenever your leading coefficient, so in this case it's x, whenever that's negative, you want to take out a negative. So I can factor out a negative 4 here. So negative 4 divided by negative 4 gives me just x. 12 divided by negative 4, because I'm taking it out, would give me a negative 3. Two numbers that multiply get negative 9, add to get 0 would be plus 3 and minus 3. So again, this portion cannot equal 0. So if I were to solve this, I would subtract the 3. Here would add a 3. X cannot equal either one of these because of this multiplying and this multiplying, this whole thing. You can't just cancel out negative 3's. You have to cancel anything that's being multiplied. So these two cancel, leaving with a negative 4, x plus 3. Here now I'm multiplying. It's not a lot different than when I am just simplifying. So you're multiplying fractions across like so. I'm actually going to factor this. I multiplied this with this. I can factor this top to be x minus 2, x plus 3. So it'd be x minus 2, x plus 3 on top times, this is x plus 5, x minus 5. So you're multiplying across. So first I'm factoring. So all 4 of these binomials are on top of the fraction because you're multiplying across. Multiplication, you multiply straight across. Here, this is just the x minus 5, x minus 5. Here, if I were to factor this, I get x plus 3, x plus 1. Again, that's from this right here. This is x plus 3, x minus 1. Add or multiply to get negative 3, add to get 4. Now since I multiply across, I'm going to simplify, but first I'm going to find my domain restrictions. So 0 cannot, anything on bottom cannot equal 0. So all of these things are on bottom of the fraction. They cannot equal 0. That means x cannot equal, if I said this cannot equal 0, I would add that 5 over, so it can't be 5 because that would make it 0. I would subtract this 3. So if x were negative 3, that would make this 0. That's no good. And right here, I would subtract the 1. So those are my restrictions. You have to state your restrictions. Now, because we have multiplying in between all of these, and right here, anything in the parentheses can cancel out if it's the exact same. So this plus 3 and this plus 3 cancel. This x minus 5 can cancel with this x minus 5 because there's one on top, there's one on bottom. That's the same thing. The reason why they cancel is because this turns into 1. This right here. And when you do 1 times anything, it's going to be itself. So what do I have left on top? I have an x minus 2, x plus 5, and an x plus 1 on bottom. So those do not cancel. So this would be my final answer. I want you to try to do the next one by yourself. B. Okay, 2x plus 8 is 2 times x minus 4, factored. X squared plus 5x plus 4, multiply to get 4, add to get 5, be 4 and 1. Multiply to get negative 16, add to get 0, 4, negative 4. So again, I'm showing you how I'm factoring. Multiply to get 16, add to get 8, positive 4, positive 4. This whole bottom portion, that cannot equal 0. So this whole thing cannot equal 0. So anything that would make that 0 is a restriction. So x cannot equal negative 4, because that would make that 0, positive 4. This would be negative 4, and this is negative 4. I don't have to write them more than once. You sure can if you want. I'm not going to mark you off on it, but I'm not going to write it more than once. So now I'm looking at, because it's multiplying in between each of these, I'm looking at what will cancel. It has to be the exact same. So I have an x plus 4 here. I have 3 x plus 4s. I only have 1 x plus 4 on top. So it doesn't matter which one I take, but it has to be the whole thing. Notice I'm taking away the whole thing wherever I'm multiplying. I do not have an x plus 1 on bottom. I do have an x minus 4 on bottom. So this whole thing cancels with this whole thing. So what I have left on top is this 2 times the x plus 1. Notice that I leave it in parentheses. On bottom, I have an x plus 4 times the x plus 4. Now you can write it like this, or you could also write it, typically you do not distribute again, but you could write it as x plus 4 squared. So either one of those ways, plus your restrictions. Okay, now we're going to get into dividing. It's just one extra step here. So first thing I'm going to do actually is factor. Okay, because this right here is negative, you would want to factor out a negative 1. You don't want your leading coefficient to be negative. So factoring out a negative 1 makes that positive. Divided by negative 1 makes that negative. I did not change anything with the problem. I'm only factoring here. So I'm going to do my domain restrictions. So anything on bottom, whenever you're looking at the bottom, that can't equal 0. So x cannot equal. I'm only looking at the bottom of my fraction. So this would be negative 1. This is also negative 1, but I only have to write it once. You can write it again. This one's also negative 1 because, again, if you set this cannot equal to 0, if you're like, how are you getting this? You can set each one of these little equations not equal to 0, and then here would subtract the 1, and here would be a positive 1. Now, I can't do anything. I'm dividing. Now here's the kicker. This first equation never changes. I'm not doing anything with this first fraction right here. But when I divide by a fraction, so it's taking this fraction, divide by a fraction. Another way that you can solve this is by multiplying by its reciprocal. So I can flip-flop this. So anything on bottom now becomes on top. Now, once I move those to the top, I still have to make sure I have those restrictions from before I flipped it. X minus 2, x plus 5. But now, once I flip this, I'm going to have extra restrictions because this portion right here cannot equal 0. So I'm going to have even more restrictions here. That was green. You can't tell that that's green, but it is green. It's hard to tell. So because of this now is on the bottom, that's another restriction for a positive 2, because I would add the 2 over. Again, if I write up the equation for x minus 2, that can't equal 0, and add the 2 over. Here, x plus 5 can't equal 0 because now it's on the bottom of the fraction. So that would give me another restriction at negative 5. Now I can rewrite it just like how I did up top with one foul swoop. You can do that. However, I'm going to go like this just because to save me time and space. When I'm multiplying now, it's like everything's on top and bottom. Now I can look for things to cancel. So I look at anything that's multiplying in between. So these are all the spots where I'm multiplying in between. It has to be that whole thing. So this whole x minus 2 can cancel with this whole x minus 2 because there's one on top, one on bottom. They simplified to just to be 1. I have an x plus 1 on top. I have an x plus 1 on bottom. They simplify to be 1. I have nothing else that can cancel. On top, I have this negative 1, and I have this x minus 1. On bottom, I have this x plus 1, and I have an x plus 5. So there's nothing more I can cancel here, but I need to have this answer with these restrictions. There's my final answer. I want you to try to do B by yourself right now. So first, I just factored. The bottom can't equal 0, so x can't equal negative 4, can't equal positive 3. The bottom cannot equal 0. So again, if I were to set this portion right here, cannot equal 0, when I divide by 2, x can't equal 0. Because there's no adding subtracting, x can't equal 0 for that spot. And I already have a positive 3. Now, dividing by this fraction, I can multiply by its reciprocal. So everything on bottom moves to top, everything on top moves to bottom. Now I have 2 more restrictions because this portion cannot equal 0. So here's a negative 1, new restriction. Here's a positive 1, new restriction. So where can I cancel? Again, now that I'm multiplying, it can be everything on top and bottom. So I'm multiplying in between each of these parentheses. So I have x plus 4 on top and bottom. I have an x minus 3 on top and bottom. I have an x plus 1 on top and bottom. What am I left with? I'm left with this 2x. So I have a 2x. And on bottom, I'm left with x minus 1. This whole thing, simplify to this. So again, I need to have this as my final answer. And there we have it. Easy peasy lemon squeezy. Have a grand day.